Welcome back everyone to another video here on the Unknown Code YouTube channel. Today we are taking a look at the LeetCode problem called Spiral Matrix. This is another medium challenge. It's not that bad, but it is a little bit challenging. And this problem states that giving an n by n matrix, return all the elements of the matrix in spiral order. So the big thing here obviously is in that spiral order. So what the heck is spiral order? Well, you can kind of see the image here, but let's hop below and take a look at a couple of examples so I can show you all what it's talking about. So for example number 1, we're going to have a matrix of 1, 2, 3, 4, 5, 6, 7, 8, 9. So here, let's go ahead and draw this out as a matrix. So 1, 2, 3, 4, 5, 6, and 7, 8, 9. Then our result will be a new array of 9. So results equal to this. So we're going to start out index 1, go to 2, go to 3. Now we kind of hit an edge, so now we need to go downwards to 6, go down to 9, go over to 8, go over to 7, go up to 4. We can't go up anymore, so we'll go over back to 5. And now we're out of items, and that will be our result. So that is the first example. The next example is a little bit larger. We're going to have a matrix equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So once again, let's turn this into a matrix. We have 1, 2, 3, 4 across the top. 5, 6, 7, 8 in the middle, and then 9, 10, 11, 12. So our result, once again, will be a new array. So we'll start out at 1 again, go over to 2, over to 3, then over to 4, then down to 8, down to 12. Then we go over to 11, over to 10, over to 9. Now we can't go anymore, so we go up to 5. Can't go up, so we go to 6, we go to 7. Then we've already done 8, so we're finished. So now it would be 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, 6, 7. So that will be how that one works. Let's go ahead and take a look at the constraints. So our constraints are pretty simple. So the first one is m is equal to matrix.length. And the second one is n is equal to matrix I.length. This is just going to be the dimensions of the matrix. We have nothing special here. Then we've got 1 is less than m, n is 1 less than or equal to 10. So this means that the length of each matrix is just going to be between 1 and 10. So this one is actually fairly small. And finally, negative 100 is less than or equal to matrix ij is less than or equal to 100. So this is just saying that the values inside the matrix are between negative 100 and 100. So nothing crazy there either. So that looks all good. Once again, the goal of this is to sequentially loop through the matrix until we reach the middle, adding those elements to some array to return. This problem is a little bit more complicated, and there's a bit more code here than some of the previous problems, but after we figure out the patterns involved, it's not too bad. We can basically view this problem as yet another state machine. We will need to keep track of 4 different states, which corresponds to which direction we're moving in. We could be going in the left, right, down, or up directions, and we'll increment to the next element depending on this state. Let's hop into some pseudocode and then walk through an example before programming the problem on LeetCode. So for this, the first thing we want to do is note the indexes of the top, left, right, and bottom rows / columns. That way we can know when we've hit one of those and change direction. Then we want to say while we have not looped through every element of the matrix. Then we want to say while we haven't reached the right edge. While we haven't reached the right, we want to add top element to result. Then when we have reached the right, we want to go and switch. And then we say while we haven't reached the bottom. So now basically we're going down, and then we want to go ahead and add those right elements to the result. Then we want to say while we haven't reached the left. Then we want to add the bottom elements to the result. And finally, while we haven't reached the top, add the left elements to the result. We will keep doing this pattern over and over until we run out of elements. So when we're out of elements, we will go ahead and return that result. So a simple enough algorithm. Let's go ahead and take a look at an example. Now this example is going to take up a little bit more space, so I'm going to try to keep the matrix on screen at all time. I don't have to try to do a little movie magic or whatever with editing. But we're going to start with an example with matrix equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we actually make this to a matrix, the top row will be 1, 2, 3. The middle row will be 4, 5, 6. And the bottom row will be 7, 8, 9. And the index of top will be 0. The index of left will be 0. The index of right will be matrix of 0.length minus 1. And bottom will be matrix.length minus 1. So now we can go ahead and start. So we're going to start out with index equal to 0 or 0, 0, which is 1. So for I equal to 0, our top is 0, obviously. Our left is 0. Our right is 2. And our bottom is 2. And our x is equal to 0. And our y is equal to 0. So like I said, starting at 0, 0. So we want to go ahead and say, so we're not at the right. not at right edge. We want to set result of I equal to matrix by x. We want to move straight to the right, so we're going to say x plus plus. Now I equal to 1, top is equal to 0 still, left is equal to 0, right is equal to 2, bottom equal to 0, or bottom equal to 2 as well, typoed. X is now equal to 1, and y is equal to 0. So once again, we're not at the right edge, because we are here at 0, 1. So obviously we haven't gone anywhere, we just went over to the right one. So that means we say result of I is equal to matrix by x, and we just say x plus plus again. So I equal to 2, our top is still equal to 0, our left is equal to 0 still, right is still equal to 2, bottom still equal to 2, our x is equal to 2, and our y is equal to 0. So now we have gone from 2 to 3, and now you can see we're on the edge, so we will have to do something about that. So now we are on the right edge. We will still go ahead and set the result of I equal to matrix by x, but this time we need to go down, and we also need to make sure we don't go up too high again. So now we're going to say top plus plus, and now we're going to say y plus plus as well. Now for I equal to 3, our top now equals 1, left is still equal to 0, right is still equal to 2, and bottom is still equal to 2. Now our x is still equal to 2, and our y is equal to 1. So now we have gone from 3 down to 6. We're right there. So now we are not at the bottom edge. So not at edge. We'll go ahead and set result of I equal to matrix yx. And we want to move straight down, so we'll say y plus plus. So now I equal to 4. Our top is still equal to 1. Left is equal to 0. Right is equal to 2. And bottom equal to 2. Our x is equal to 2. And y is equal to 2. This time we have hit the bottom edge. Hit bottom edge. So now we still want to set result of I equal to matrix yx. And now we need to switch directions basically. So we are going to go ahead and say that the right edge is going to be minus minus. So the new right edge will be 1. And we also want to say x minus minus. So now I equal 5. Our top is equal to 1 still. Our left is equal to 0. Our right is equal to 1. And our bottom is equal to 2. And now our x is equal to 1. And our y is equal to 2. So we went from 9. Now we're at 8. So we are not at the left edge. So not at edge. So all we'll do is set result I equal to matrix yx. And then this will be x minus minus. For I equal to 6, our top is still equal to 1. Our left is equal to 0. Our right is equal to 1. Bottom equal to 2. And now our x is equal to 0. And our y is equal to 2. So now we've gone from 8 over to 7. Now we are at the left edge. So hit left edge. We will have to do something to that. But we'll go ahead and set result of I equal to matrix yx. And now we want to go upwards. So we will go ahead and say bottom minus minus. And we will say y minus minus as well. Now I equal to 7. Our top is equal to 1. Left is equal to 0. Our right is equal to 1. And our bottom is equal to 1. Our x is still 0. And our y is equal to 1. Now we are at 4. And we have hit the new top. So we have hit the top edge. We'll have to deal with that. But we still need to set result of I equal to matrix yx. Now, since we've hit the top edge, we'll go ahead and say left plus plus. And we'll go ahead and say x plus plus as well. So now I equal to 8. Our top is equal to 1 still. Our left is equal to 1. Our right is equal to 1. And our bottom is equal to 1. Our x is equal to 1. And our y is equal to 1. Now we've kind of hit all edges here. We're basically done. So we will go ahead and set result of I equal to matrix yx. And that's all we really have left, because if we come back up here, we went from 4 to 5 in the middle and we have nothing else to do. Then it is return result, which is equal to 1, 2, 3, 6, 9, 8, 4, 5, which should be correct. So that looks good. Hopefully I can get all of that editing and stuff done and working good with the matrix and showing all of those steps. So now let's go ahead and hop over to LeetCode and take a look at how we can solve this over there. So inside here, we're going to start with int top equal to 0 and int left equal to 0. Similar to how we had in our pseudocode, then we'll have int right is equal to matrix of 0 dot length minus 1. Then our int bottom will be matrix dot length minus 1. Then we'll go ahead and make our result. So list integer result is equal to a new array list of integers. Then we'll go ahead and say while result.size is not equal to matrix.length times matrix0.length. This is just basically saying not the size of m times n. Then what we want to go ahead and do is say for int I equal to left, I is less than or equal to right, and I plus plus. We're going to say result.add, and we're going to add matrix top I. Then at this for loop, we'll say top plus plus. We've reached the right side. Then we'll say for int I equal to top, I is less than bottom, I plus plus, result.add. We'll say matrix I right. So now we're moving downwards. Then at the end of this, we want to say right minus minus. Then we'll say if top minus 1 is not equal to bottom. This will deal with a small like side case and things that might happen if we don't have at least 3 indexes here. Then we'll say for int I is equal to right, I is greater than or equal to left, and I minus minus. So now we're going backwards towards 0. We're going to say result.add matrix bottom I. Then outside this for loop and if statement, we'll say bottom minus minus. And finally, we'll go ahead and see if left is not equal to right plus 1. So if we have area or space to do this, we'll go ahead and say for int I is equal to bottom, I is greater than or equal to top, and I minus minus. So once again, we're going back up towards 0. And we'll say result.add matrix I left. And at the bottom of this if statement, we'll say left plus plus. And then outside of the final while loop, we'll return result. And fingers crossed I didn't fat finger any typing or mess anything up. I'm not very good with getting the less than or equal signs very correct for some reason. I always type them wrong. So fingers crossed and submit. Cool. No debug, so we get a 0 millisecond runtime, which will beat 100%. The memory complexity isn't the greatest, but it is what it is. As always, if you guys did enjoy or find some value, please leave a like, comment, subscribe. It helps out a ton with the YouTube algorithm. And as always, I'm Ethan, an encoder. Hope you guys have a great day, and I'll see you all in the next video.